This is lesson 5.1. In lesson 5.1, we're going to talk about systems of equations. And a system of equations is a set of two or more linear equations in the same variable. So, for example, y equals 5x plus 2. So they both will have x and y, whose solution is an ordered pair that is true for all equations in the system. So sometimes it's two, sometimes it's more than two equations, but the ordered pair has to be true for both or all of them in order for it to be a solution. So if we're testing out 2, 5 for these two equations here in this system, we're going to plug in 2 for x in both, and we're going to plug in 5 for y in both. So if I'm working with my first equation, I'm going to plug in 2 for x. So I'll have 2 plus, and then I'm going to plug in 5 for y. So 2 plus 5 equals 7. Does 2 plus 5 is 7. Does 7 equal 7? Yes, it's a solution for that one. Now I'm going to do the same thing for the second equation. So again, plug in 2 for x and 5 for y. So I have 2 times 2 minus 3 times 5 equals negative 11. So 2 times 2 gives us 4. 3 times 5 gives us 15. 4 minus 15 is negative 11. Does negative 11 equal negative 11? Yes, it does. That's a solution. So 2, 5 is a solution to the system. For example, B, well, example 1, part B, this was A. We're going to test this point and these two. So we've got the point negative 2, 0. So we have, this time it's in slope-intercept form. So we're going to start with the y value equal to the rest of the equation here. So I have 0 equals negative 2 times x, and this time x is negative 2, minus 4. So negative 2 times negative 2 is 4. 4 minus 4 is 0. Does 0 equal 0? Yes. For part 2, I have y equals x plus 4. So again, I'm going to plug in 0 for x equals x, or in this case 2. Oops, sorry, negative 2 plus 4. Negative 2 plus 4 is positive 2. Does positive 2 equal 0? No. So because this point is not true for both equations, then negative 2, 0 is not a solution. So basically, you're just plugging in the values for x and y and testing to see if it works for both of the equations in the system. Another way to figure out the solution to a system is to graph the system. So up there, they gave us points and they wanted us to test whether it was a solution. This time, they're going to give us the equations and they want us to graph to find the solution. So I'm going to start with this first one. My y-intercept is positive 5, so I'm going to start up here at positive 5. My slope is negative 2, so I'm going to go down 2 and right 1. Down 2 and right 1. Get my ruler here, make a straight line. There we go. And then I'm going to graph my second equation here. Y-intercept of negative 1, and I have a slope of 4, so I'm going to go up 4 and right 1. Connect these dots. Now we kind of already can see that solution because it happened to line up right there on that other line. So solution is the spot on the graph where the two lines intersect each other. So they intersect each other right here, right at that point there. And we're going to name that point 1, 3. So it's the ordered pair 1, 3 as the solution for that system. So the spot where those two lines overlap, the point 1, 3. If we're talking about real world situations, this says a roofing contractor buys 15 bundles of shingles and 8 rolls of roofing paper for $640. In a second purchase, the contractor buys 8 bundles of shingles and 2 rolls of roofing paper for $296. Find the price per bundle of shingles and the price per roll of roofing paper. So we have to look at what these equations are going to look like. So we have a variable for shingles and we have a variable for roofing paper. All right. So if we take a look, this first one, we had 15 bundles of shingles and 8 rolls of roofing paper. So I'm going to say that the shingles are x and the roofing paper is y. So I have 15 bundles of shingles. I don't know how many bundles or how much those bundles cost, but I know I had 15 of them. Plus I had 8 rolls of roofing paper. But again, I don't know how much those cost, for a total of $640. In the second purchase, we had 8 bundles of shingles and 2 rolls of roofing paper. And this price was $296. So we've got 8x plus 2y equals $296. So what we want to do here is we want to be able to graph these lines on this axis here. And I only have the first quadrant because we're talking about items, right? We're talking about rolls of paper, bundles of shingles. We're talking about money here. So I can't have negative shingles and I can't have negative rolls of paper. So that's why we're only working in that first quadrant right there. So when I'm looking at these, what I need to do is I need to find out where can I graph these different lines here on my coordinate here. So what I'm going to do is I would suggest putting it into slope-intercept form first because it's going to make it a little bit easier in order to graph. So if I want to put it in slope-intercept form, I have to subtract 15x from both sides. So we're going to have 8y equals negative 15x plus 640. And then we're going to divide each part by 8. So I have y equals negative 15x, 15x plus 64 would be 80. So I know my y-intercept here is 80. So if I'm going to count these, we'll count them by 20. So I'll just skip every other. All right. So I know I have a point at 80 here. And then I need to know where it crosses the other one. So actually, what might have worked better for us is because it's in standard form, if we just found our x and y intercepts. So we know our y-intercept is 80. And if we plug in 0 for y, 640 divided by 15, that's going to give us about 42.6 repeating. So that's really actually not going to fit on here. So if I counted my x-axis, and I have 8, 16, 24, 32. What I'm looking for, I can also use my slope. So if I'm going down 15, it's kind of tricky just the way that this is lined up to try to match with the other line. So we could go down approximately 15. So we're almost down to this next line, and we'd have to go over 8. So we're looking about right here, kind of in this general area. And then 2 of them would be 30, so that's about here, right there. Get that going here. There it is. See how it kind of goes that way? Oops, didn't use my color. There we go. And then for my second one, if I want to find my y-intercept, so 296 divided by 2, it's going to give us 148. So we've got 140 right here. So we're going to have to kind of estimate a little bit. So 150 would be exactly halfway, so let's go just slightly under halfway between those two lines there. And then our x-intercept is going to be 296 divided by 8, which gives us 37. So if this is 40 right here, we have to get close. So halfway between 32 and 40 would be about 36. We're a little over halfway this time. And we want to look and see where these two lines overlap one another. There we go. So this one, because we don't have exact lines, we have to estimate the solution for this. So if I'm looking at it, it looks like these two lines cross about right here. So we're making an estimation. And when we estimate, it looks like we're crossing at about 30, a little bit more than 32. So we'll call it, I think I'm a little bit farther over. I didn't get my lines quite right, but it's about 32.20. So some of them we have to estimate, and then we could double check. So if we plug in that point 32.20, 15 times 32 is 480, plus 8 times 20 would give us a total of 640, so that worked out. And then we test again, so 8 times 32 gives us 256, plus 2 times 20, which is 40, gives us 296 for that one. So the point 32.20 would work. Our graph is just a little bit off because when I was estimating down here for my x-intercept, I was off just a little bit in terms of where it would line up. So that would kind of slide it a little bit more for me. But if we test it and it's not quite right, we can always make adjustments. So if, let's say, we had tested this as like 31.20 and we didn't get it quite right, we could look and say, okay, well, let's see, it's almost 32. Let's try 32 to double check. And then we found out, 32 would work for our x value for that. So for some of these, it's a little tricky. You got to estimate those values. But where those two lines overlap one another, that's the solution for our system. This is lesson 5.2. In lesson 5.2, we're going to continue solving systems of equations, but this time we're going to be using what's called substitution. And substitution works kind of like a substitute teacher does. So the substitute teacher comes in and steps in place of the teacher for that day. And in substitution, we are going to have a variable that's going to get replaced by something that it is equal to. So for example, here in part A of example 1, we see that y is equal to negative 2x minus 9. I can replace this entire piece of information in place of y in the other equation. So we're going to show how to do that. So y is equal to negative 2x minus 9, and our equation that we're plugging it into is 6x minus 5y equals negative 19. Now, whenever I'm solving systems using substitution, I always want to make sure that I have one equation that has either y equals or x equals. So in this case, I have y equals negative 2x minus 9. So that entire piece of information is going to replace y in my other equation. So I have 6x minus 5. Now remember, it means negative 5 times y. So everything that y is equal to is going to go in the parentheses. So negative 2x minus 9. And that's equal negative 19. From here, we're going to simplify. So I have negative 5 times negative 2x is positive 10x. Negative 5 times negative 9 is positive 45. And I'm going to bring down the 6x I haven't used yet. And the negative 19 I haven't used over there. Now I'm going to combine my like terms. So 6x plus 10x is 16x plus 45 equals negative 19. Then I'm going to subtract 45 from both sides. So we know that we have negative 19 minus 45 is going to give us negative 64. Those cancel. We have 16x that we're bringing down. Our last step is to divide both sides by 16. And we find that x equals negative 4. Now that I know x, remember that the solution to a system is always an ordered pair. So now that I know that x is equal to negative 4, I can plug it back in and discover what my y value is going to be. My suggestion, if I have an equation that starts y equals and I'm looking for y, plug in your x value for that equation. So I'm going to plug what I just found, x is negative 4. I'm going to plug that into this original equation here for x. So I have y equals negative 2 times my value of x, which is negative 4, minus 9. So negative 2 times negative 4 is positive 8. Positive 8 minus 9. We have that y equals negative 1. So the solution for my ordered pair, the solution for my system is an ordered pair, and it's going to be that x is negative 4 and y is -1. So the point -1 would be the spot, if I were to graph it, where these two lines would overlap one another. Now for part B, notice I don't have an equation right now that has x equals or y equals just yet. So what I want to do is solve one of them in order to have x equals or y equals. And I would suggest, since this one just has 5y, the easiest way to solve or to simplify would be to solve that one for y. So for part B, I'm going to start with my 5y equals 2x plus 19. And I'm going to solve for y. So to get y by itself, I have to divide each term by 5. So now I have that y equals 2/5 x plus 19/5. Now I'm going to leave that as 19/5, and you'll see in a minute why I do that. Sometimes it makes sense to make it a decimal. Sometimes it makes sense to make it a mixed number. Most of the time, it's great just to leave it as an improper fraction. Okay, so I know now that y is equal to 2/5 x plus 19/5. All of that is going to get put in for y in my top equation here. So I have 4x plus 5 times 2/5 x plus 19/5, and it's equal to 7. Now, you'll notice here, since we start with distributing, if I multiply these fractions with the denominator 5 by a whole number of 5, they will cross-cancel those denominators. So that means I'm going to be left with 4x plus 2x plus 19 equals 7. So it really took those fractions right away for us. 4x plus 2x, so when I combine my like terms, I have 6x plus 19 equals 7. Subtract 19 from both sides. We have 6x equals -12. Divide by 6. And we find that x equals -2. So now I'm going to use this equation here that I solved for y, and I'm going to plug in that -2 for x into that equation there. So I have, slide that up a little bit, y equals 2/5 times -2 plus 19/5. So when I'm simplifying, I have y equals -2 times -2 is -4/5 plus 19/5. -4/5 plus 19/5 is 15/5, which simplifies to be 3. So y equals 3. So the solution for this system is the ordered pair -2, +3. And our last example that we're going to take a look at. Comedy Club earns $1,088 from an opening night performance and $1,183 for a second performance. On opening night, the club sells 68 adult tickets and 136 student tickets. For the second performance, the club sells 79 adult tickets and 140 student tickets. What is the price of each type of ticket? First, we have to write an equation, right? So we have two totals, 1,088 and 1,183. So we know we've got those two totals for our equations. So I have it equals 1088 and I have it equals 1183. For this opening night, we know that there were 68 adult tickets, 136 student tickets. So let's call the adult tickets the x, and we're going to call the student tickets the y. So we've got 68x plus 136y, and that was for opening night, which was a total of 1088. And then the second night, we had 79 adult tickets, so 79x, and 140 student tickets, so plus 140y. Just like in our previous example, we don't have an equation that starts out x equals or y equals. So what we want to do is we want to solve one of these equations to get x equals or y equals. So I'm going to choose the top one, and I'm going to solve this one for y. So I had 68x plus 136y equals 1088. So I'm going to solve it for y. So I'm going to subtract 68x. That's going to give me 136y equals -68x plus 1088. Remember, I don't put them together because they're not like terms. That's why I put this one off to the side. I'm going to divide each term by 136. That leaves me with y equals -1/2 x plus 8. So now, sorry about that. Everything here gets plugged in for y in my second equation. So I have 79x plus 140 times -1/2 x plus 8. And this is equal to 1183. So we start by distributing into our parentheses. Bring down the 79x. We have 140 times -1/2 x is -70x. And 140 times 8 is positive 1120. Still equal to 1183. 79x minus 70x is 9x plus 1120 equals 1183. We're going to subtract 1120 from both sides. Bring down this 9x here. 1183 minus 1120 is 63. Divide by 9. And we find out that x equals 7. Now that I know x equals 7, I'm going to plug that back in. I would suggest, again, using the equation where I already found out y is equal to something. So I have y equals -1/2 times 7 plus 8. So -1/2 times 7 is -3.5. So half of 7 is 3.5 plus 8. So y equals -3.5 plus 8 is 4.5. Now I use the decimal this time because we need to know, what do these numbers represent? Well, the question asked us, what is the price of each type of ticket? So this is talking about money, and when we're talking about money, it makes a whole lot more sense to write it as a decimal than to leave it as a fraction. So what this means is that student tickets, remember student tickets were the y value. So student tickets cost $4.50, and adult tickets, those were the x values. Adult tickets cost $7. So yes, it's the ordered pair 4.57. So, or sorry, 7, 4.5, like that. But when we're talking about this information that we were given, if we want to interpret what that point means, it means that the adult tickets or the x-axis are $7 and the student tickets or the y-axis are $4.50. This is lesson 5.3. In lesson 5.3, we're going to continue to talk about solving systems. Only this time, we're going to talk about solving systems using a method called elimination. And elimination is when we are adding or subtracting two equations in order to get rid of or eliminate one variable completely from both equations. So if we look at example 1a, we have 3x plus 2y equals 7. And we have in our second equation, negative 3x plus 4y equals 5. So what I want you to think about when you're looking at these systems, especially using the elimination method, first of all, standard form equations are the greatest format for doing the elimination method because they're set up so that the x's and y's are often stacked with one another. But what you're looking for is when we solved equations back at the beginning of the year, remember we tried to figure out, well, what can I do to eliminate or make 0 for my number? Or when I was left with variables, how can I move it to the other side? How can I make it 0? So it's the same idea, but now we're looking at comparing together. How can I add these together to make 0? And sometimes we don't have to do any extra math in order to eliminate. So if I look at this system here, my y's, I've got 2y and 4y. If I were to add these together, neither one of them would eliminate to make 0. If I look at the x's, positive 3x, negative 3x. If I add 3x and negative 3x, I get 0. So right there, without any extra work, I am able to eliminate my x's. So I have negative 3x plus 3x. When we combine them together, they make 0. Actually, I'll use my color for that. There we go. And then I'm going to add straight down here. So 2y plus 4y is positive 6y. 7 plus 5 is 12. So we're basically adding straight down on both sides. 6y plus 0 is 6y equals 12. So I really just simplified that side. And then my last step, divide both sides by 6. And I discover that y equals 12 divided by 6 is 2. So if I already have a positive and a negative same number in the same variable, then I don't have to do any extra steps to eliminate that variable. So now I have the 2 that I need for part of my point, that y value. Now I need to plug it back in to find the x value. So if I plug this in, I can choose either equation. Truthfully, I often choose the one that doesn't have any negative numbers, so that makes it easier for me. So I'm going to put it into that first one. So I have 3x plus, and since it's 2y, I have 2 times y, or 2 times 2, because y is equal to 2 now, equals 7. 2 times 2 is 4. Bring down that 3x, bring down the 7. We're going to subtract 4 from both sides. Bring down our 3x. 7 minus 4 is 3. Divide both sides by 3. And we find that our x value is 1. So for that first system, solving it using elimination, we had the ordered pair of 1, 2. So x was 1 and y was 2. Now when I look at example B, I'm looking at my x's, I'm looking at my y's. Neither one of them have the same number in the, like I don't have 2 10s, I don't have 2 6s, something like that. So I'm going to have to change one of my equations in order to be able to eliminate. So let's take a look here. Letter B. We have negative 10x plus 3y equals 1. We have negative 5x minus 6y equals 23. So what I'm going to be doing is looking for an option so that I can have two numbers that are the same, and I need to have one be positive and one be negative. So if I were to focus simply on my first numbers, I know I can make 5 become 10. So if I multiplied 5 by 2, I would get 10. Well, the problem is if I wanted to eliminate my x's, then I would have to multiply by negative 2 in order to eliminate. So show you this, multiply by negative 2. So we're going to distribute to every piece. So my top equation doesn't change. Negative 10x plus 3y equals 1. Negative 2 times negative 5x is positive 10x. Negative 2 times negative 6y is positive 12y. Negative 2 times positive 23 is negative 46. Now that I have my positive and negative of the same number in the same variable, I can add my two equations together. So negative 10 plus negative 10x plus x. Oh my goodness. Negative 10x plus 10x is 0. 3y plus 12y is 15y. 1 plus negative 46 is negative 45. Divide both sides by 15, and we discover that y equals negative 3. So now I have to plug it back in, and I'm going to use this same equation here, that negative 5x, just because I have a little bit smaller numbers. So I have negative 5x minus 6 times negative 3 equals 23. It also is going to help me to get a positive number here, just some of the things I often will think about. So negative 5x, negative 6 times negative 3 is positive 18 equals 23. Subtract 18 from both sides. We have negative 5x equals 5. Divide by negative 5. And we find that x equals negative 1. So for that system, we have our ordered pair of negative 1, negative 3. Now, something I want to point out to you, and some of you may have already noticed this. Notice I multiplied by negative 2 so I could make this negative 5 become positive 10. But if you notice the y's, look how the y's are already a positive and a negative. I also could have chosen to just multiply that top equation by positive 2, and it would have given me my positive 6y, and this already is negative 6y. So there's multiple ways that you can try this, but that's one way. If you don't want to multiply by negatives, if you already have a positive and a negative, you can try multiplying so that it will equal, like for example, multiplying by 2 would give me that positive 6 to cancel with the negative 6. Example C. we have negative 5x plus 1/2 y equals 3. And we have 4x minus 2y equals negative 8. So sometimes we have fractions. And I'll be honest with you, I often will do whatever I can to eliminate the fractions when I'm doing elimination, if possible, because it makes life a lot easier. So if I'm looking at these, look, I have a positive and a negative already, kind of like I just talked about in example B. So I already have a positive and a negative. And if I want, I can eliminate this 1/2. But how am I going to get half to become 2? Well, half of what number equals 2? 4. Half of 4 equals 2. So I'm going to multiply the entire top equation by positive 4. Because like I said, I already have a positive and negative. So I want to keep that top one positive. So we're going to multiply it here, all 3 pieces. So that gives me negative 20x plus 4 times 1/2 is positive 2y equals 3. And then my bottom equation doesn't change. So 4x minus 2y equals negative 8. We're going to add these together. Negative 20x plus 4x is negative 16x. My y's canceled out. Besides that, there we go. Equals 3 minus 8. Whoops, I forgot to multiply right there. There we go. So 4 times 3 would give us 12. There we go. 12 plus negative 8 gives us positive 4. And our last step here, divide by negative 16. And we get that x equals negative, simplifying always whenever possible, so negative 1/4. So it doesn't matter if I find y first like I did in the first two, or if I find x first like I did in this one. Once we get one of them, we're going to plug it into an equation so that we can find the other one. Now, since I got x equals negative 1/4 and I have to plug it into one of these two, I'm going to choose to plug it into the second one because I know with a denominator of 4 and this whole number of 4, I'm going to be able to cancel some things out. So I have 4 times negative 1/4 minus 2y equals negative 8. So 4 times negative 1/4 is negative 1. Bring down the things I didn't use yet. I'm going to add 1 to both sides. So I have negative 2y equals negative 7. I'm going to divide by negative 2. And I have y equals negative 7 divided by negative 2 is positive 7/2. And it's perfectly acceptable and encouraged to leave it as an improper fraction, unless you are told differently in the question. So if you're asked to write it as an improper or as a mixed number, then write it as a mixed number. Otherwise, you're welcome to leave it improper. So x is negative 1/4, y is 7/2. That is our point of where they intersect one another. And our last example, example 2. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each type of van? So the first thing we have to do in order to figure out the cost is we have to write a system ourselves. So we need to decide which is which. So I'm going to just say that the large vans are going to be my X values, and then my small vans are going to be my Y values. Also important in this problem is our total cost. So when we're looking at our total cost, we have let's see, $235,000 for the first set, and we have $160,000 for the second set. So if I'm looking at it, I have 5 large. So I have my X's, we said were the large ones. So I have 5 X's plus 2 small. So that was our Y, 2 small equals $235,000. For location B, I had 2 large and 3 small for a total of $160,000. So look at the top. It said we had 7 large total ones. 5 and 2 gives us our 7 large. And we had 5 small. So 2 and 3 gave us our 5 small. So they used up all of the trucks. Now we have to try and eliminate one of these variables. So something that I want you to notice is that all of the numbers here are positive. One other option we can do, notice at the very beginning, it said that we can add or subtract 2 equations. Since both of these equations are positive right now and all of the numbers are positive, I'm going to choose to use subtraction. So that when I'm doing my multiplication, I can deal with all positive numbers. So also, I stacked my larger equation on the top. That's going to make my life easier too in order to try and subtract. So in order to make them the same, one of our variables, we have to multiply. So I'm going to focus on eliminating my y variables since those numbers are a little bit smaller. So in order to make this the same as down here, I have to multiply both equations this time. So 2 times 3 would give me 6, and 3 times 2 would give me 6. So I'm going to multiply the top everything by 3 and the bottom by 2. All right, draw my arrows in here. Okay, so 3 times 5x gives us 15x. 3 times 2y gives us 6y. 3 times 235,000 gives us 705,000. 2 times 2x gives us 4x. 2 times 3y gives us 6y. And 2 times 160,000 gives us 320,000. So like I mentioned before, this time I'm going to use subtraction. So I'm going to subtract those 2 equations. So top to bottom, I'm just going to subtract. So 15x minus 4x gives us 11x. My 6y minus 6y makes 0. 705,000 minus 320,000 leaves us with 385,000. In order to get x, we got to divide the last thing by 11. And we find out that x equals 35,000. Now that I know x equals 35,000, I can choose to plug it back into one of my equations. I'm going to choose the bottom one. Again, a little bit smaller numbers to work with here. So I've got 2 times 35,000 plus 3y equals 160,000. 2 times 35,000 is 70,000. Bring down the 3y and the 160,000 we haven't used yet. Subtract 70,000 from both sides. We have to bring down our 3y equals 160,000 minus 70,000 is 90,000. Divide by 3. And we discover that y, oops, wrong marker, equals 30,000. So for this question, what does it mean? It means that the large van, because large was X, large vans cost $35,000, and our small vans cost $30,000. So it is a point on the graph, but we have to know what that point represents. So the point 35,000, 30,000 means that its large vans are $35,000 and small vans are $30,000.